Okay, here's the review for your quiz tomorrow. It's covers sections 6 through 8 in Unit 1. Unit 1, sections 6 through 8. Oh, that just made that blurry. Okay, so number 1, it says write the equation of the piecewise function f of x shown below. So off to the side, we're going to start with f of x. And notice that there are two pieces of lines. So we're going to have two lines, and they're both lines, right? A line is in the form, just don't forget, y is in the form mx plus b. So for the first line, what can you notice what let's look at this one right here. What's the y-intercept of this line? See it crosses through 0? So it has a y-intercept of 0. What do you think the slope is of this line? Looks like it's going down to right 1, down to right 1. If you look closely, I think you can tell that the slope's -2. It's going down, slope's -2. So for that first piece, you don't need to write the y because this is f of x. This is y equals, and it's plus 0. It's going through the 0. Now, what is the domain for this? What x's does it cover? So you look at the x right here. It covers from 1, 0, -1. It's all the numbers less than 1. But there's an open circle. So you're going to have a less than sign. All the x's less than 1 are what is covered for that first line. So x is less than 1. It's 1, 0, -1. It has all these. Now the second line, you really can't tell what the y-intercept is, but you might be able to figure out what the slope is. The slope is definitely positive because it's going up. Looks to me like it's up 1 over 1. Up 1 over 1. Looks to me like the slope is 1. So if I kept going, what would the y-intercept be? If I started at this point right here and went down 1, left 1, I would be at -2. The y-intercept, even though it doesn't touch it, if you kept going, the y-intercept would be -2. So this is x minus 2. That's the line x minus 2. Now, what x's does this cover? It looks like the first one is 1. Then the next one is 2 something, 3 something. So it's going to be the ones greater than or equal to 1. Notice the closed dot means includes the 1 and everything greater than that. And that's how you write a piecewise function. Identify the transformations of f of x. So this is what you have. So what is this? What's being done first? If you have a 3 on the outside of something, 3 being multiplied on the outside, anytime it's on the outside, you mention the word vertical. So you'd say vertical stretch, factor of 3. If it's in the inside with x, you should mention horizontal. Horizontal, now this is a shift 5 to the right. And that's done. So on this one, you have two things on the outside. You have this and you have this. So the first one is a reflection over the x-axis. What that actually is switching is the y-coordinate. So it is changing the y, but you say reflection over the x-axis. That changes the y to its opposite. Then this 5 is on the outside, so you're going to say vertical shift down 5. Now the 3 is on the inside, so that's horizontal. But anything on the inside, you do the opposite. So you're going to say horizontal compression by a factor of 1/3. A factor of 1/3. Write the function using the parent graph after it has been reflected. Okay, so we're going to write a new function. Everything's going to be involved with this x right here. So first it has been reflected over the y-axis. That goes on the inside. Horizontally compressed by a factor of 0.5. So if it's a 1/2 and it's inside, it's going to end up being a 2 out front. Horizontal compression by a factor of 1/2 means it's inside, it flips to 2. And shifted 2 to the left. Now, because it's shifted 2 to the left, I need parentheses. Because that's also going to go on the inside. Shifted to the left means that should be a plus 2. But you need the parentheses. This is 2 left, reflection on the y-axis, horizontal compression of 1/2. If you forget the parentheses, you will miss this problem. So you have to separate by parentheses when you're doing these. So use the graph of f of x to graph the following transformations. G of x equals this. This is a reflection over the y-axis, and it's a horizontal compression by a factor of 1/2. So you're changing, reflection over the y-axis means you're changing the x and you're changing x again. So you're reflecting first. So reflecting over the y. So first thing we're going to do is reflect. So if you just reflected, it would look like this. Okay, if you're just oh wait, sorry guys, I'm reflecting over the wrong axis. Reflect over the y-axis. So it would look like this. So that's -4, so it'd be 4. So that's reflection over the y-axis. And then this one reflected over the y-axis would be, it was 2, 0, it'd be -2, 0. This is 3, -2, so it's going to be -3, -2, and 4, 0. So it would look like this. I'm going to do this in red. So, well, I don't want to do it in red. So this is new, and this is new. But then you have by a factor of 1/2. So basically that means horizontal compression, where this was going over 4, is now going to be half of that. So see how this one's going over 4? Horizontal compression. Okay, see how this one's going over 2? It's now going to be only over by 1, half of that. So it's going to be like this. Okay, and then this one's half of that. So take half of that 4. So this piece right here is this one. Now this one, how it went over 2, you're only going to go over 1. And this one went over 4, so you're going to go over 2. So the red is your answer.
I need the homework that we were supposed to do.
On Friday?
Yeah, I guess.
Were you not here Friday?
I was. Right? I don't know. I didn't. Was I supposed to pick it up?
We were doing one on it in class, so I don't know what you were doing when I was on it in class. Some people turned it in. Let me stop this video. Give me a second. Okay, I'm going to pick this up here in a second.